In this video, we are going to introduce some of the principles of counting. Now, counting might seem like a familiar activity. It turns out that counting is actually a very, very useful thing to do. It's often useful to count things in both math and computer science. And it comes up an awful lot of the time. So here's a few cases where we might need to count something. So one case is when we ask ourselves, hey, I have a computational operation and I'd like to understand how many mini operations it will take me to perform some kind of task. So, for example, maybe I have a sorting algorithm. I want to sort a list of length n, and I want to know, as a function of n, roughly how many operations it's going to take me in order to sort that list. And so to do that, I need to find a way to mathematically count those operations. And one of the reasons this is so important is that this leads very directly into questions of like how fast your program is going to run. Does your computer feel smooth and responsive, or does it feel halting and jerky? Another application of counting is when we ask ourselves, hey, how hard is it going to be for me to, for example, find the best route between two cities? I might need to search through the possible routes between two cities. So if I want to find some kind of best solution to a problem, well, not always, but often, I might need to ask myself, how many possible solutions are there? What's the space of all possible solutions that I need to search through to find the best ones? Sometimes we call this a search cost. One more. Often in computing, we think about randomness, and so we might need to do things like count the number of ways that a random process could have a particular outcome. So an example of this would be asking, hey, if I roll two six-sided die and add together the results, what's the number of ways that I could get eight as a result there? And this is going to relate directly to the probability that I get eight, and then I can define more complicated things as well there. So we're going to consider all of these in different parts of the course. All these different applications of counting. Okay, I want to know how long it's going to take an algorithm to run. I want to know how large a search space is. I want to know the probabilities of different kinds of outcomes of events. And counting, fancy counting, is going to be our key to all of these questions. When I say fancy counting, I'm talking about what in the field of mathematics we often call combinatorics. So combinatorics means fancy counting. When we are considering all the mathematical tools and techniques for counting complex structures, so not just one, two, three, but counting the number of solutions to some kind of complicated task, counting the number of operations defined through some kind of complex recurrence relation. So this kind of fancy counting, counting where we're using complicated mathematical tools, that's the field of combinatorics. Many times when we're doing a counting problem, or as we'll now call it, a combinatorics problem, when we're doing a combinatorics problem, we're often going to consider this as asking about the cardinality of a set. So if I ask to count the number of solutions to a task, for example, such as the number of possible routes, the way I might express that is, hey, if I have the set of all possible routes, what is the size of that set? That's the same question as asking the number of possible routes. And so we'll often frame our counting problem in the following form. Let S be the set of all possible solutions to a problem, and we'll ask, hey, what is the size or cardinality of S? This will be the way that we do many of our combinatorics problems.